Well, here I am on my soapbox again. I hope you don't mind. When your grandparents or great-grandparents were in school, you don't know it, but they studied in 7th and 8th grade a topic that we just put in as for a few days in our algebra curriculum: ratio and proportion and just percentages. And your ancestors had the advantage because they had 2 full years of this. And I know that because of the Depression and everything, many people dropped out of school before they got to high school proper. And this 7th and 8th grade curriculum that was so good at teaching them how to solve ratios and proportions, or work problems in ratio and proportion and do percentages, helped them, many people, to succeed in technical jobs and to go very far. And now we leave it out. I don't know why. I think that they think that now we have machines that can do some of the problems that you don't need, and they keep saying we need to give them real-world problems. But to my mind, it's like we're asking you to build a house but never teaching you how to use a hammer. It's kind of silly. And we need to understand ratio and proportions. Now, I have taught, as I've said, for over 35 years, and in these latter years, I have not seen any students who really understood the properties of proportions and how they can be rearranged, even the brightest kids who are in calculus. I asked them, did anybody ever teach you how you could rearrange a proportion? They all say no. And it depresses me because this is where the power is, and where the complaints from some international businesses have come to America and said that the American workers are just not ready to help work in their factories because they just don't have the skills, and they need to look for college graduates and even sometimes graduate students. We had that complaint that they needed graduate students before they got people who could do what back in Japan any student could do, because they were more on the traditional path and learned how to manipulate proportions and do the kind of real-world problems. And the problems that were just common in the 1800s and in the early 1900s are just, I don't know, just left out. And they just think that somehow, since we've got modern kids, we can accelerate to something else. But anyway, we need to go over that if you don't understand ratios. And I hope you'll indulge me, because I'm going to ask you maybe more than what your teacher wants you to know. But I hope that you'll learn it anyway. Thanks. It's good for you. Bye. Oh, I'm going to use one of my programs to do the teaching about them. So pay attention. Stay tuned. Here I am looking at the main screen of Howe-Two software, and I'm going to need this marker. So I'm going to pull up this marker and press M and minimize it down to the taskbar so I can pull it back up again and minimize it. So you can see it'll say marker when we're looking at the marker. Now we're going to look at foundational topics. We're going here to the center of the field to proportions. It's really ratio and proportions. We're going to click on this, and here comes the definition. A proportion is an equality between 2 ratios. Okay? So I have this little animation going. If A is to B as C is to D, then C is to A. These are things that are true, and how you can turn things around. And I've tried to animate these, the ways that these proportions can be rearranged and still be true. Now, what I want to show you here is I'm going to bring up this marker, and if you have this, if A is to B as C is to D, then any way you rearrange it, so long as when you cross multiply or use the property of proportions that the product of the means is equal to the product of the extremes. All right, there. I'm into saying that a ratio is an equality between 2 ratios, and this is the first term in the ratio, and this is the second term in the proportion. I mean, this is the second one, and this one's the third, and this is the fourth. And this proportion could also be written A is to B as C is to D. These 2 things are saying the same thing. A is to B, C is to D. Now, these different parts of the proportion have names, vocabulary assigned to them. The ones on the end are called the extremes. They're the extremist. And these two in the middle are called the means, which in math usually means middle. Got that? Means are the ones in the middle, and the extremes are the ones on the end. Or if you look at it in this more traditional form, the extremes are this A and D, and the means are this B and C, although they don't have to be those letters. Now, whenever somebody asks you, is a rearrangement legal or not, you ask yourself, well, if I use the property, the product of the means, that would be these two, is equal to the product of the extremes. If that holds true, then it is a legal rearrangement. For instance, here, if we did that, the product of the means would be A times D equals the product of the extremes, B times C. A times D equals B times C. Notice that this is multiplied. This is a proportion symbol with two dots. This is not the same notation as this. And if you see here, if we cross multiply here, and we see that we get, sure enough, A times D is equal to B times C stays true. So this is a legal rearrangement. I'm going to minimize this, except it would be good if I use the right. And then let's see if we can pull up some other things that are true. Oh, this one's all right here. Now look, if this is true, and this is a known proportion, the question is, how would we know that this is also a legal proportion? Well, the product of the means here is B times C equals A times D. Now, if we do the product of the means here, we get BC plus BD equals, and the extremes, AD plus BD, and then if we use the subtraction property of equality, because we see we've got a BD on both sides, subtract off the BD, subtract off the BD, and we get BC equals AD. And so this is a perfectly legal rearrangement of this proportion. That's what I call patterns in the proportion. I'm going to minimize this and we'll get back to the marker, and let's see if we can do the problems that I have here with patterns. I have never had a teacher come to the lab and do the patterns because it's not on the standardized tests. It's so sad. New problem. If this is true, what is the equivalent to A minus B over B? The pattern is, if what we did on this side, we do to the other side. So here we went A minus B over B. This side would have to be C minus D over D. Now, how would we know that that's the same? We could bring up the marker and we could put it to the test. Is this going to be, it's going to be AD minus BD equals BC minus BD, and we add BD to both sides, and we find out, sure enough, that AD is equal to BC. This is legal. And I'm going to minimize this, and we're going to check to see if our answer is correct. Oh, there's the check button. I forgot where I put it. So we got that one right. Patterns right 1. New problem. Can you think of what would be equivalent here? It would be, have to do to this side what's done to this side. And if we don't believe it, we could confirm it like we did on the last one. But let's just see if we can set up the pattern. It's C plus D over D would be another legal proportion. Check, we win. New problem. If A over B is equal to C over D, then A over C must be the same as B over D. Some students get very upset when I rearrange a proportion like this, but you can rearrange a proportion, and this is going to help you a lot in geometry. As long as you see that if you put down a simple thing like this and you say, can I rearrange it? Cross multiply this and check it out. It's okay as long as AD equals BC. Look, AD equals BC. Sure enough, that's okay. B over A. If I turn this one upside down, it's still legal. If I turn this one upside down, check, we win. And this is that left side upside down. B over A. This is going to be D over C. I hope that you'll play with this a little bit until this starts to look like old hat and you understand it completely. And now we'll move on to problems. The problems are kind of easy. Okay, I'm ready to start and show you some problems here with this proportion problem. And I'm going to click this button because I don't really want to do a lot of fractional arithmetic, only integer answers. And let's pick level 1. Make it easy. So new problem. Here we have 12x. This is going to be, let's bring up the marker. 12x equals 9 times 84. Now, if you ever get stuck out on a planet without a calculator, you might want to know some tricks about the calculator. We could multiply 9 times 84, not my favorite sort of thing. We've got the 12 here. I see this is an even number. This is an even number. Why don't I divide both sides? Let's see, this is easily divisible by 4. This one's divisible by, why don't I divide this side by 4 and this side by 4, and we could get down to an equivalent thing would be 3x is equal to 9 times 21. Oh, I see that this side is divisible by 3, and this side is divisible by 3. Why don't I just say x is equal to 3 times 21, which is 63. Wasn't that easier than multiplying 9 times 84? So let's put that down here, 63. I have to minimize this, 63. Put in the answer. Check, we win. See, isn't math beautiful, the way you can save some energy if you know enough? These are the kinds of problems that you can work. You should work them until you get really good at them. The practical real-world problems that use proportions are quite a bit in the realm of medicine. I had a student once, I mentioned her before, she made a big impression on me. After she graduated, turns out that one of my neighbors was her friend of hers, and she didn't know where I lived, but she saw me going to the mailbox, and she came and knocked on my door and said, "Remember me? You tried to teach me math." And she asked me if I wouldn't teach her the math that she needed to have for her nursing career. She had tried to go on to get her RN, but she just didn't know this math, which was needed to figure out medicines and percentage of solutions. She needed the ratio and proportions and percentages straightened out in her mind so that she could actually pass the tests that were required for her to become a more qualified nurse. You have to have these tools to do some of the really necessary problems in this practical world we live in. Now, not all problems work this way, but you'd have to have calculus to get to the harder ones. But I don't want any of you to not be able to do ratio and proportions. So use this problem. I advise you to get really good at it, both the patterns and the problems. Thanks. Bye.